Good afternoon, everyone, and happy Friday from the Select Group. My name is Lee Wallace Dodd. I am with our experience team. We're excited to have each of you here today and also thrilled to have Rudy Nash with us. Before I turn things over to Rudy, a couple of housekeeping things on our end. This meeting is being recorded, so you will be able to reference it back in our YouTube thread after this call. I will also be sure to share the recording with you after it becomes available to us. And I will also accompany that with a brief survey. We would love to have your feedback on any additional webinars that you would like to join us for. We do have an upcoming webinar next week. Next week, we have a webinar on neurodiversity. And the week following, we have a webinar on cybersecurity and addressing the cybersecurity workforce shortage. We invite you to join us for each of those. Those are published on our LinkedIn page as well. With all of that being said, I'm going to turn things over to Rudy to begin his presentation. I would encourage you to utilize the chat feature. Feel free to drop in any questions that you have throughout the presentation. And of course, we'll have time for Q&A at the end. Rudy, the floor is all yours.
Excellent. Thank you, Lee Wallace. I appreciate it. Good afternoon and happy Friday, everyone. As Lee Wallace said, my name is Rudy Nash. By way of background, I have about 25 years or so in the software development field, and more specifically in the development of software for collecting and analyzing data. And today's presentation is going to focus on the fundamentals of those activities. We're not going to get real deep into any one aspect of it, but we will touch on the surface level of what is data, the types of data that we might think about collecting and analyzing, how we go about analyzing, what types of analysis we can perform, why we would want to do this, what is the value of the data that we're collecting, and how can we potentially monetize that data over time. And we'll get into some very clear examples of that. And then we'll summarize a little bit at the end about the different platforms and tools that are available to perform this analysis. And then if you're interested potentially in a career, what are some of the ways that you can get started in moving forward with data analysis or data science career, whatever. That's the new word today for what we're talking about, data science. So let's jump in with some fundamental stuff. First, let's figure out, what is data? What are we talking about when we talk about data? Well, data is literally, it surrounds us. It's everywhere. It's every raindrop. It's every car that's going down the highway. It's every flight that's coming into and out of an airport. It's crops that are grown. It's everything you do on your cell phone. It's every security camera, every doorbell nowadays. Of course, all of your web activity is producing data, and now your television, of course, smart TVs are producing and monitoring, tons of data on what you're watching and how often you're watching it. One thing that I was remiss in saying in the beginning, and I want to add this now, is that I recently went through a seminar on how to present on Zoom, and because it's totally different than presenting in person. And one of the things that was recommended to me is that at the end of every slide, I give a 15-second pause where I don't say anything, and I allow people to jump in or type chat in questions. I can't do 15 seconds, but I'm going to count to like 5 and be quiet and let you digest the stuff that I've just said for every slide, and then I'll move on to the next one. And that's about as long as I can stay quiet. Okay. So now that we have an idea of what data is, let's talk a little bit about what the analytics or analysis of that data is, right? Given all of these things that are happening around us in the world, things that we're collecting data on, what is the analysis or the analytics piece of all that data, right? Well, very simply, all we're doing is taking the raw data that we're collecting, and we're trying to draw a conclusion out of it, right? We're trying to figure out, okay, this happened yesterday, what might happen today? Or are my numbers, my sales headed in the right direction? Or if there's this many cars on the highway, do I need to build a bigger highway, right? And we're applying some mathematical and statistical concepts to try to detect patterns in this data. So over time, the more data we collect, the more intelligence we can get about a trend, and maybe project with more accuracy future probabilities of what might be coming down the pipeline. Machine learning techniques and obviously computers have gone a long way towards helping us to improve our learning and our understanding of the data as we move forward. And I'll have some clear-cut examples of that coming up in a bit. And then finally, in the end, what we want to be able to do is present that research and effectively communicate our findings to other human beings, right? Because human understanding of this is really what it's all about, right? So effectively communicating and presenting our findings is crucial to what we're doing. So let's talk about, sorry, my 5-second pause. Okay, let's talk about the 4 primary types of data analysis that can take place, right? So first we have what we call descriptive. Basically, it's a comprehensive or accurate assessment or understanding of what's happened in the past or what is happening right now, real time, okay? And for this, I'm going to use a mall, an example of people moving through a mall. Imagine, if you will, I own the mall, and I want to know how much traffic is coming into the mall. I want to be able to see where they're going, how long they're staying in certain places of the mall, so that I can do things like adjust my rents for the businesses that are in the most popular or congested areas of the mall. I want to charge them more because they have more foot traffic walking past their door, right? So my ability to collect that data on where people are moving, how often how long they're staying in a spot, how many of them are there, what time of day they're there, etc. Those are all things that allow me to potentially increase the profit of my leasers in the mall. Obviously, a lot of this is pre-COVID, and we'll get into touching on that in a bit. But that's one type of data analysis, looking at the past or current events to try to figure out what's happening, right? Descriptive. Then there's diagnostic. I want to understand why things are happening. So for example, in my mall example, I see that on the right-hand side of the mall, or on the northeast quadrant there's a lot of red, which indicates in this particular example that there's more people, more density, right? So why are there more people in that part of the mall? Well, if I knew that Mike Tyson was at the Lids store signing autographs at the time that this data was being presented, that would have been a diagnostic solution. I would know that there's more people there because they're in line to see Mike Tyson, and I'm able to track their phones and see how much data is being pushed up as they're taking pictures and videos of Mike Tyson, right? So pretty good example of diagnostic analysis. The next type that we want to talk about is predictive. So I know a lot about what's happened in the past, and as I get smarter about the trends and the analysis of past activity, I should, with some level of accuracy, be able to predict what's going to happen in the future. Maybe the next day or a week or maybe years from now, I can predict what's coming. A very important aspect of data analysis. And if I look at something like foot traffic in my mall, and I go back a year and I see, okay, Saturdays, Fridays nights, Saturdays, very busy times, I can usually, with some level of accuracy, predict what my busiest times in this mall are going to be. Another thing, though, that might affect this would be weather. So if I can integrate and layer different types of data or dissimilar data into this analysis, I can get more accurate in terms of my predictions, because when it's stormy and or cold or whatever have you, it might affect the traffic that's coming to my mall. And then lastly, we have prescriptive analysis, right? So basically, this is the art of looking at pieces of data, deciding based on what I'm looking at, a course of action to take for something that I need to do. So an example of this might be and the HVAC service or systems at the mall, right? So if I'm able to see that the temperature in the mall is rising, and my fan is spinning at the same rate, but the blower motor is consuming a lot more electricity than normal, but I'm not, the temperature is rising, the air isn't staying cool, then from those different aspects of data that I'm collecting, I might be able to deduce that I need to change the blower motor, right? So it's tying a set of dissimilar data points together to come up with some prescriptive or measure of action that would fix a problem, perhaps, or maybe lead to something being more efficient. So my 5-second pause. And we'll go to the next slide. All right. So in terms of the types of data that we're going to be looking for over in general, there's really 3 kind of types that I categorize data as. There's present obvious data, the stuff that we knowingly are collecting. There's hidden or less obvious data, and I'll give you an example of that in a second. And then there's dissimilar data, basically items, pieces of data that are seemingly unrelated on the surface, but can have impact on outcomes if you are able to tie them together and understand the relationships. Because most things in this world are related in some fashion. It's just not always obvious how that occurs. So let's talk about an example of what I mean by this. So present data or obvious data. And some of you may have seen this example. It's widely known if you're in this field on the internet. There's lots of articles on this. But in World War II, when Allied aircraft were fighting the battle over Britain, these aircraft would come back to the base and return, and they'd be riddled with bullet holes. And aircraft engineers and scientists would analyze the bullet holes over the airplane and think, okay, we need to reinforce these parts of the plane because that's where the bullets are penetrating the aircraft. And that on the surface seemed to make sense, but there's something that's missing here. Something's not quite right, right? And that is this, that these aircraft that they analyzed, none of them had bullet holes in these 4 areas of the plane. They were all absent. And it's not because they weren't getting hit with bullet holes there. It's for the most obvious reason, which is that these spots could not tolerate bullet impacts, and that as a result, the aircraft would crash and it would never return to base. So of their sample, the only ones that they could look at were the ones that made it back that were being hit in the less sensitive areas of the plane, and that the parts of the plane that were highly sensitive, that were getting hit with bullets, were not coming back to the base. So as a result, they decided to reinforce these areas in the circles and improve the survivability of the aircraft. Not an obvious thing on the surface, but when you analyze and start looking at the other hidden pieces of data, i.e. these airplanes were not coming back, that's where you were able to deduce where the true vulnerability was. And then some dissimilar aspect of data may be weather, right? So during the war, they didn't have the ability, the weather kind of sensing and knowledge that we have today. It was very rudimentary, but had they had detailed weather reports, cloud cover knowledge like we have today, wind velocities, sunrise directions, things like that, there may have been different outcomes in those battles as a result. So these are like the different types of data that we'll be dealing with as we go through this presentation. And my 5-second pause. Okay, so I mentioned earlier that data has value, but where is the value in data? How do we know, or how do we decide what's valuable in what we're looking at, right? So on this chart I have on the right here, on the lower left, we have data assets. In other words, this is an area where we're just collecting data. And then on the right, we have data monetization. This is where we're actually able to take data and monetize it or move it into some value that it doesn't have on the surface. How does that happen, right? So raw data, when we first collect it, ones and zeros, whatever the case may be, very little value other than the fact that we're collecting data on assets. So capturing it and enriching it is the first step, right? Using IT tools to collect data out of ports or over the internet or off a Wi-Fi network or from a people counting camera or a security camera. And that's the first step. And then we apply some rudimentary form of analysis to it. Okay, there were 10 people that walked through the door. There were 100 people that walked through the door. They visited 40 websites in the last hour, or whatever the case may be, right? This is kind of the first step in cleansing and increasing our opportunity to create value out of the data. Then there's enriching it. This is what we call using data to make decisions, right, based on our analysis. Let's go back to the original or the example that I used earlier of the mall and the density of people in the mall in certain areas, being able to charge those storefronts more for that space because they had more foot traffic, right? I'm monetizing my knowledge of foot traffic, so I'm monetizing that data. Or looking at the example of the HVAC system, where I knew the blower motor was starting to have a problem, so I can preemptively replace that before other stressors on the HVAC system occur, or the mall got so hot it drove out all the people. Again, valuing our data. And then lastly is the kind of the holy grail of data valuation, and that is repurposing it for customer facing or revenue generating opportunities. And there are lots of these, and I'm going to give you a pretty stunning one in the next slide. I'm going to pause for 5 seconds here. Okay, so data valuation in an obvious form is in this example that I'm going to give you. So we probably all remember last year when COVID hit in March, when it impacted most of our population, and the airlines basically stopped flying. They just stopped, right? One day people were getting on planes and flying around, and the next day that all ended. And airlines only make their money by moving people from A to B in a tin can, right? If they're not flying people around, they're not making any money. So airlines like United and American, whose market caps are like $9 and $8 billion respectively, were literally not bringing in any revenue, but they still had to pay their employees. They still had to, they had fuel orders they were paying for. They had all these things that were going on, but they were not bringing in any revenue. And they didn't know when that was going to end, because if you remember in the early days of COVID, we had no idea how long the extent of shutting down the airlines and stopping travel was going to take. So they turned to other sources of monetization, and namely, they turned to their data. So United and American had data valuation companies. These are companies that value data based on its content. They had them come in and say, okay, what is our frequent flyer data worth? That, these airlines have been around for decades. They've been collecting frequent flyer information, names, email addresses, phone numbers, flight patterns, like travel habits of people and stuff. What is that data worth to us as a company? And these data valuation companies came in and said, well, your United Mileage Plus data is worth about $20 billion, United Airlines, and American's Advantage data was worth about $31 billion. Clearly, almost triple what, or at least double, these airlines are worth as a company. And they used this data valuation to go out and secure lines of credit to keep themselves operating. And what they've done is since turned and sold this data out to other companies that want to know about their frequent flyers and what their travel habits are. So obviously, and there's 1,000 other examples that we can talk about, but data has real value, not just in terms of decision making and analysis, but monetary value as well. It's kind of the new gold rush, and that's why you'll hear a lot of terms, the whole data science, train of thought that's coming about now, and the ability to understand, collect, and monetize data is really coming to the forefront of business operations today. My 5-second pause. Okay, what has helped us to get here? Well, computers, right? You couldn't do the kind of data analysis we're doing today by hand. It's not possible. And in fact, only 10, 20 years ago, we couldn't do the kind of data analysis we're doing today thanks to machine learning, right? So basically, software algorithms and a science that it gets smarter as we feed more data into a model. And there are lots of different models. There are lots of different algorithms that are available out there. And I'll touch on some of the boot camps and some of the things later in here and how to get involved in these. But basically, in a nutshell, what it boils down to is that the evolution of computers, the speed of a computer, and the software and the application of science into those software platforms and algorithms are allowing us to learn about our data more and more as we pipe more data into the models. We get smarter as we go forward. So again, back to our predictive analytics model, right? Analyzing historical data to forecast future outcomes. The most obvious place that this occurs is the stock market. Now, there are a lot of other things that are looked at, but by and large, trends and analysis that have occurred in the past that lead up to predictors of what's going to happen in the future. Most of the trades that occur in the stock market today are computer-generated trades. They are not me sitting here, looking at a screen going, "Oh, I like Microsoft today." They are actually computers analyzing thousands, if not millions, of data points and looking for trends and activities and using triggers and indicators to decide when to buy, sell, short, whatever stocks. And most of the stock market today trades occur through computer software. Very few of them are done by a human anymore. And as such, as I said, these models, as we're feeding and piping these millions of data points into these models, they're getting smarter and learning more and more and becoming more accurate over time. Okay. Another great example of this is our ability to plot weather, hurricane tracking, just weather prediction in general. But if you think about, back in the day, launching weather balloons to get temperature densities at different altitudes, moisture content, airflow, all the different factors that go into making up weather. And I remember hurricanes, when I was younger, the cone of uncertainty would be, half the East Coast. Well, now they're able to get it down to a state or two of where it's going to impact the country. And usually it doesn't deviate too much off of their center line once they start making predictions. So the ability to predict, weather and specifically hurricanes, but even tornadoes, the ability to look at a storm and predict within seconds. I believe that this is an area that's likely for tornado formation. In fact, now they have a whole new category of warning, which is, a computer indicated tornado. Like, nobody's actually seen it, but the computer believes strong enough that a tornado is occurring in this area, and they'll actually issue warnings based on a computer prediction, as most of you have probably seen. So these enhancements, these machine learning enhancements, have allowed us to improve our predictive tools and models immensely over time. And I'll pause here. Okay, so now that we have all this great data and we're able to monetize and analyze, and we're smart and we understand what's going on, the next key aspect of data analysis or analytics is presentation, visualization, the ability to show our findings and present it so that it can be understood by a human being, right? And because we're human, our eyes are drawn to certain visuals, right? And we need to be able to see data in a way that's easy for us to understand. Now, obviously, if it's data that's being acted on by a computer, by a computer for a computer, as in the stock market and things like that, it's not as important. But if you're going to put data in front of a person, and ask them to understand it, then you need to understand how humans think and see and visualize things. For example, if I put a spreadsheet in front of you with numbers versus a graph, it's way more easy for me as a human being in my brain and eyes to understand that on these charts, New York and Illinois had the worst, or West Virginia had the worst sales for the period, right? Rather than looking at the set of numbers, sales data that are in the upper left-hand corner, I can look at these graphs and these charts and see very clearly what the trend is, who's leading, who's lagging, etc. And of course, the same thing holds true with this example of a line chart, right? Where the numbers on the bottom are generating the line charts above, but I can see instantly by looking at the charts who's outpacing the other in sales and where the spikes are and the trends and things like that. So just keeping in mind that if you need to present data to a person, you need to put it in a way where you appeal to the human aspect of the visualization, right? You can't just throw a set of numbers that you've discovered out there and expect someone to ingest it. So that's why business intelligence platforms, monitoring platforms are now all the rage, because they just do that. They allow us to easily interpret and understand massive amounts of data, dissimilar, disassociated data points, bringing them together to make a very clear picture for us in important topics such as, weather, sales trends, etc. The list goes on and on and on. And I'll pause here. Okay, one other thing then I wanted to throw out you here are some of the tools that are used for this. And I'm not going to get into any of these specifically, but I just wanted to throw up a list of some of the more popular ones, how we can visualize, collect and visualize our data. And believe it or not, I put Excel at the top because it's probably the one that most people have access to. That's very easy to use and understand, and has a lot of power in terms of the ability to present and visualize data, especially in terms of financial data and things like that. And then there's others, Tableau, ClickView, Fusion charts. I encourage you to go and explore each one of these. They have their own unique aspects of, some of them are driven towards software developers. Some of them are just for layman users, but they all generally support ingesting large volumes of data and producing visualization as an output for that data. And some of them even go as far as allowing you to set up, logic pathing and deterministic kind of outcomes, where if this happens and that happens, do this. A very easy, simple example might be if I'm monitoring, for example, in a hotel, right? The AC is on, the electricity is running, and the temperature is 95 degrees outside, and you open the window. And the sensor on the window is going to tell the AC to turn off until the window is closed, and then the AC will come back on, right? Very simple integration of multiple dissimilar data points coming together to drive an outcome. And some of these just visualization tools also provide for that kind of connect the dots kind of thing. And I'll pause real quick here. Is the image on the right? I'm sorry, while I was just taking a pause, someone asked. I know the image on the right is just a sample of some other visualization techniques that are going on. But many of these do provide this type of output in terms of bar chart styles, line graphs, plots, radial dials, etc. Thank you for that question. Okay, we'll go ahead and move on to the next slide, which is what are the next steps? How do I get involved in this? Well, beyond the numerous higher education courses that are offered at universities across this country. There are also many boot camps that are available. Many of these are free or at some level free to start. And then if you find that you're interested, you can continue on. These are just a few of them: Microsoft Coding Dojo, Code Academy, Khan Academy, AWS. I think Google has one. There's just so many, too many to list. A quick search on the internet will result in a plethora of options for you on how to kind of dive in and determine if this is something that you're interested in doing, or if you want to take it to the next level in terms of your understanding of the data science and data analysis in general. And with that, I am going to, I think, open up the floor here to questions. Let's see here. Oh, no, we got one more slide. My apologies. Summary. So data surrounds us, obviously, everywhere in our lives. Everything that is happening is producing data in some form or fashion. Collecting, reviewing, and presenting this data is the art of data analytics or data science. The four main types of analysis are descriptive, diagnostic, predictive, and prescriptive. Basically, understanding what's happening or has happened, using that data to come up with a solution or to predict what might come in the future, and prescriptive being the ability to come up with a form of action, a course of action based on the data. Data can obviously be obvious, I know what I'm collecting, or it can be hidden, less obvious, and we'll go back to the example of the aircraft that weren't returning to base, and obviously dissimilar, not obviously related in terms of air temperature outside, window sensor, HVAC running examples, many things like that in the world where we have multiple dissimilar data points that wouldn't seemingly be related, but can be brought together to form some sort of outcome or insight. Data can have value, a lot of value, when it's analyzed and monetized correctly. And we talked a little bit about the airline example. There are a plethora of examples out there on how we can monetize data and where the value in data lies. Machine learning has obviously advanced this science incredibly over the last several decades. The speed of computers and the software algorithms and the models that we're feeding into them now are changing the way that this entire science works. And lastly, if you're going to present this data to a human, your visualization and presentation techniques are key to gaining human understanding and comprehension of all this data that we're working so hard to collect and analyze. And that is my last slide. And with that, I'll open up the floor.
Thanks, Rudy. Feel free to drop in your questions into the chat or unmute your line and you can ask Rudy the question directly. I'll give a couple seconds.
Okay, so we have a question in chat, what is meant by data cleaning? So that's a great question. In the act of collecting data, sometimes anomalies occur, or let's take the example of let's use an agile research firm. So there are firms out there that post surveys out to the public where, let's say, a company is trying to decide on a landing page for their mobile assets, right? So what they're trying to do is drive people to click through to register for something. So they have two different mobile experiences, and they want to do like A/B testing to see which one is more valuable, like is going to drive more people to the click through. So they'll pay a data research firm to run a survey to some element of the population, to have them decide for them, which one is going to work best. Well, that now you're dealing with human beings and the element of human interaction to take that survey. Some people will just click through a survey real quick just to get paid, so they don't spend time analyzing or trying to understand the intent of the survey. Some people will try to take a survey multiple times, so you'll get bias in terms of repetition. So those data points that you've collected on the surface may seem accurate and valuable, but in fact they're not. They're creating ugliness, so to speak, within your data, right? They're not clean. They're creating anomalies. So what you want to do is have techniques available to cleanse your data, to get rid of those red herrings or anomalous types of activity, and generate a more accurate outcome. And I hope that answers that question. Another question is, how can we quickly identify hidden dissimilar data to value its worth to a report without having to spend too much time on them? Good question. So like most things, we learn more as we do, right? So the longer we are doing something, the more we tend to learn about it, the more we tend to gain insight. I know when I first started working in this field, a lot of the processes that we're talking about today were manual, where you would sit and generate output visualization to try to see from a human perspective what's going on, and draw conclusions and decisions from that. As I mentioned earlier, a lot of that now is being done by machine learning and algorithms. So in today's world, the most popular way to quickly identify hidden or dissimilar relationships is through a computer, through machine learning, where you consistently feed data points into a model, and the model learns from the data, and over time it's able to recognize these nuances in relationship between the dissimilar data points that you're piping into it. An example of this would be voting activity based on like weather in an area, or the impact of a political climate on sales in a certain part of the country. Believe it or not, all of these things have relationship. They're just not as obvious on the surface when we're doing human analysis, because it's very hard to see, to draw those relationships between the data. But when you start feeding in all of these dissimilar data points into a computer, it is very good, can be very good, the algorithms, at learning and seeing and understanding over time the relationship between, oh, the political climate in this part of the country is having an impact on sales or production of goods, or whatever the case may be. And that becomes evident over long, periods of time, and feeding data into these algorithms. Again, I hope that went towards answering your question. Another question, you mentioned data patterns. Could you please elaborate a little bit more on data patterns? How are data patterns identified? Yeah, so patterns are just a repetition of data and its presentation. For example, if you've ever done a search on Google for a restaurant, you'll see that if the restaurant is known in Google, which most of them are nowadays, Google has a timeline that they plot below their little block of information on the restaurant. And the timeline basically says, this is the time frame that this restaurant is usually busy, right? So on the East Coast, let's say 6 p.m. to 8 p.m. And you'll see a spike in the activity, and then it will go down. That is a pattern. That is a trend that has been recognized by Google as this is the time the restaurant is the most busy, and it's repetitious, and they're able to see it and repeat it. And that is what we consider a pattern in the data. And that's how we identify them. And I hope that answered your question. Yeah. Okay. That's all I see in chat. Does anybody want to speak up and ask a question on the mic? Oh, another. What are the career opportunities in data analytics? Yeah, so they're bountiful. data scientists, data science, data analytics, whatever the term is you want to use for this, is one of the most popular, fastest growing opportunities in the workforce today, because of the proliferation of IoT devices and the data that we're collecting off of them. And I mentioned some of them earlier, cameras, sensors for everything from people walking past the store to, your microwave is turned on or turned off. I mean, there are literally projected to be, I think the number is about 20 billion or so devices collecting or producing data, more than there are today within the next 5 years. And another frightening statistic that I heard the other day that I'll share with you is that within the next 25 years, 50% of the jobs that are held today by humans will be held by computers. And those computers will be analyzing and producing data. So this is probably one of the fastest growing, most lucrative fields available today. So your opportunity is boundless. The key is to get yourself into an educational program, whether it's a boot camp, coding camp, or higher education, higher learning university or school, and get yourself some certification in these fields, in these areas, and you'll vault yourself up to the top of the chain in terms of opportunity. My pleasure. Any other questions?
All right.
Well,
thank you.
Yeah.
I believe that is all the questions that I see in the chat. Thank you again to everyone for joining us, and thank you, Rudy, for your time with us on this Friday afternoon.